Okay, everybody. Today we are analyzing graphs of functions. All right, everybody. So when I have the graph of a function, first of all, refresh my memory. How do you even tell if a graph is a function or not?
The vertical line.
Yes, we are checking the vertical line test real quick. Make sure that as I pass a vertical line, it never hits more than one. So yes, this is certainly a function. There's lots of things that I can now tell about this graph. We talked the other day about finding the domain and range by looking at the graph. So we already know that. Do you know how to tell if it's a polynomial or what degree it is? Just by looking at it?
Yes, I used to.
It's not a guarantee, but you can certainly have an idea. Jake? Yeah, so one clue is to look at how many X-intercepts you have. This one has 3, so it's a pretty safe bet that this thing is going to be a cubic function. There would be some X cubed. That's not always a guarantee because you could have, for example, if you have a quadratic doesn't have to ever touch the x-axis, but it could hit up to twice. All right, anywho, another couple things that we can tell about a graph just by looking at it is where it's increasing and decreasing. So we say a function is increasing on an interval if for any x1, x2 in the interval x1 is less than x2 implies that the function of x1 is less than the function evaluated at x2. Lots of mumbo jumbo. What does that really mean? It just means as you trace your function from left to right, the function is going up. That's all it means. So if I were to take a look at the function that we have above here, if I want to know where this thing is increasing, as I trace from left to right, if my finger is going up, there is a section of the graph where I am increasing. Okay, so I could say that this thing is increasing from, I'm coming from negative infinity all the way up to right about -1. And then now I'm obviously decreasing, right? If I'm going down. But then look, I pick it up again. I'm going to increase again from, where am I at? 3 to positive infinity. Oh, this should be closed. Sorry. Okay, so that's easy enough, right? So we're increasing over those 2 intervals from negative infinity up to -1, and then again from +3 to positive infinity. And then if I wanted to do where am I decreasing? Who can tell me that? Where is this graph decreasing? From what x value to what x value? Evan?
-1 to 3.
I agree with you, from -1 to 3. And you know what? I was right before. I would not want to use hard brackets here. I'm so sorry. Let me explain why. I knew I had that as smooth for a reason. Smooth, smooth, change them to smooth. Let me tell you why. Smooth, smooth. What is the graph doing exactly at -1? Is it increasing or is it decreasing exactly at -1? Jake? It's not doing either, right? It's not going up or it's going down. It's reaching the highest point that it's going to get right in this area. Just like when you throw a ball up in the air, there's a split second where it's not going up anymore and it hasn't started to come back down yet. It's not doing anything. Throw it up, fraction of a second before it comes back down. That's what's happening exactly at -1. It's not increasing or decreasing. So that's why I want to use smooth, because I actually don't want to include -1 because it's not actually increasing exactly at -1. It's not doing anything. Same thing is happening over here at 3, right? Where it's sort of, I'm bottoming out here. So it's not yet increasing. It's not doing anything at exactly 3. It's just, it's turning around. It's its turning point. So I don't want to actually include those values. Does that make sense? Because exactly at that moment, they're not increasing or decreasing, it's changing. Okay, so flip. Okay, so we just did that, so that's fine. Now, we were just talking about this point right here. That is not the highest point that the graph will ever get to, right? Because it does go off to positive infinity over here. So I don't want to say that that's, remember when you were doing quadratics and you had like the max and the min when you graphed the parabola? Remember that? Well, this is, I mean, it's kind of a max, but it's not the max of the whole graph. So what we use a different term. We call them a relative max or a relative minimum if it's the lowest point. That just means, hey, this isn't the highest point that the whole graph is going to get to, but it's the highest point of this area. Okay, so this we would refer to as a relative max. And then if I'm bottoming out like I am over here, that would just be a relative min or minimum. Okay, easy peasy. All right, flip, because that's all the bottom talks about. Okay, so we have a relative max when x equals -1, a min at x equals 3. All right, let's take a look at a graph like this one down at the bottom. It is possible that you have a piece of your graph that's just kind of flat. So here, we are not increasing, we're not decreasing, we would just be constant there. Okay. Take a look at what we can describe about this graph. Where is it increasing? Only this chunk here between 3 off to positive infinity. Where are we decreasing? Here from -infinity all the way up to -2. We are constant in between -2 and a +3. And this one has 2 relative mins. It happens once right here at -2 and then once right here at a +3. This one doesn't happen to have a relative max, and that's okay. These are just going to keep going up forever. So I don't have a relative max in this case. So far, so good? Easy peasy? Lemon squeezy. All right. Let's see what we can figure out on these 2 examples back here. Whoop. See how much of it you can fill in. I'll give you a minute or 2. For any intercepts that you don't know exactly, just give your best estimate. Henry, you finished? Which one? So take your finger and trace the graph. Where's your finger going up? Over what values of X? I'd say right here it's going up, right? And right here. Right? Would you agree? Because here I'm going down. Do you agree or no?
Yeah.
Okay, so I have increasing here. I'm going to decrease here. I'm going to increase here. So what I need to do to write my answer for where I'm increasing, I need to say this chunk. And I only care about the X values. I don't care about Y. So this goes off forever. So from negative infinity all the way up until I hit an X value of -1. Aren't I increasing over that whole chunk? So negative infinity all the way up to -1. Just don't include the -1 because right at that second, it's not going up or down. Now there's another chunk where I'm increasing. It's here from X values of 3 to positive infinity. So now you tell me, where is it decreasing?
It's -1 to X value 3.
Yes. So we would write that as -1 to 3, like that. Okay, let's fill in the other parts here. Domain, who's got it? Quick, quick. Domain. Jake, tell me.
Negative infinity, comma infinity.
Yes, all reals. Nothing is out of bounds here. The range. Braylon?
I had negative infinity, comma 1.
So, can't you just say negative infinity all the way to positive infinity?
Okay.
Right? Yeah, I don't think you have any breaks here. So range, same thing, negative to positive. X-intercepts, how many are there? 3, yes. So this one we're gonna have to approximate, I don't know, -1.7-ish. Whatever you put, as long as it's kind of close to that. It looks, I don't know, 0.6, 0 and 4. There's my X-intercepts. Only Y-intercept I have is at 0. Where is this graph constant? It's not. I don't have a flat line anywhere. So even though I have it changing for a split second, it's not constant there. It's just a point where it's changing. A constant would be a flat line somewhere on my graph. I don't have that. So I just don't have it. As far as a relative max, I'm having that happen once when X is equal to -1. And I think that's it, right? That would be the only one that I would consider a relative max. Relative min, where's that happening? Do I have any? Jake?
X is equal to 3.
Correct, when X is equal to 3. Easy enough? See, I told you this section wasn't bad. So go ahead and try the bottom one while I hand out tonight's homework. Okay, so real quick. Let's see how fast we can do the bottom one here. Domain. I say all reals. As I'm moving from left to right. I know that there's an open dot here, but I have a closed dot here, so it's fine. I have a closed dot here. I can get all the way from one side to the other with no gaps horizontally. I don't care if I have to jump up and down. I want to make sure I can go horizontally all the way across, and I can. Range, different story. This graph doesn't even exist until I hit -4. But once I hit -4, let's see, yeah, then I can go off to positive infinity. So my range, y just has to be greater than or equal to -4. X-intercepts, looks like I have 2 of them. I don't know, -2.2. And then another one at, well, it's just before the 5, I don't know, 4.9. Y-intercept, I've got one, a 3. Where am I increasing? Braylon, go ahead.
Negative.
So hold on, you're gonna trace from left to right. So this section, you're actually going down, right? This part's, we're always talking moving from left to right.
Even though this arrow is pointing up.
It just means that it's gonna keep going that way. But as I trace from left to right, you trace the graph from left to right, whatever it's doing. I'm going down, I'm going constant, I'm going down a little bit, but here's where I'm increasing. Right there. So I would say increasing from 4 to positive infinity. Decreasing, I have 2 areas where that's happening, from negative infinity all the way up until I hit -1. And then again, just for this little section, from 3 to 4. And now I'm wondering, right here, I think I would include that. Like I put a hard bracket there because I'm not changing. Yeah. Well, am I? Yeah. Ooh. I'm second guessing myself on that. I'm gonna go with a bracket. 3 to 4. Where am I constant? I do have a section where I'm constant. When x is greater than -1, but not equal to it, right? Because it doesn't exist there. All the way up until 3. Relative max. What do you guys think? There's been some debate over this one, and the consensus is kind of that there isn't one. Because I don't, I mean, yes, this is, but it's not like, this isn't like the one highest point in its little region, because they're all there. So I guess if you're gonna say it, everybody's kind of tied for this top spot. So I don't know, and we went back and forth on this, and we kind of agreed that there isn't one. Relative min though, I'd have one here and then another one over here. So when x is equal to -1, and again when x is equal to 4. Easy enough? All right, so you have your homework in front of you. When you go to submit, guys, feel free to just take 2 pictures. Just open it up. I can see both of those at the same time, and I can see both of these at the same time. You don't have to submit 4 separate ones. I can zoom in, no problem. Okay?
For the last one, why would there be a bracket when the decreasing point?
So So, because right at that point, it's not changing. See how this one's, it's changing from decreasing to increasing. So at that split second. So I'm gonna go double check with Miss Swanson, but I think right there it is decreasing because I'm not changing. You get what I'm saying?
Yeah.
So let me go ask her opinion. Well, what did I put in my key from last year? Decreasing. Oh, see, I have it this smooth. I feel like it's a bracket there though. Let me ask her and I'll come back. All right. She thinks the same as me. She's like, you could kind of say it either way. So I guess I would just take either on it. We were discussing right here. Do you include, so it's certainly decreasing right here, but do you include 3 as part, like with a hard bracket or an open? Because is it decreasing at 3 like that split second? I say yes. So I would use a hard bracket. At 4, it's not because that's that one split second mark's changing.
I don't get it.
Yeah.
Am I doing this first?
Give me 1 second. Let me just stop the video so there's not like 15 minutes of nothing at the end.